All right, you guys, I wanted to do just a short lesson to review what we learned today in class on factoring expressions. So what you see here in front of you are just two area models to kind of help us to make sense of the difference between standard form and factored form. When we think about standard form, we're really looking at what is the area of the figure. And when we look at factored form, it's kind of like finding out like what are the individual side lengths of the figure. So one of those is more of like a complete answer, like after we multiply everything together, that would be standard form. And the other is more like what would the problem be? What numbers do I need to multiply together to get that answer? So just take a minute here. You can even pause the video and examine these two so that you can understand the difference between what factored form looks like and what standard form looks like. Our goal for today is to be able to go from factored form into standard form, which is what we do using the distributive property, right? We distribute to go from factored to standard form. But what we want to do today is sort of reverse the process and go from standard form into factored form. And that's where finding the GCF comes into play. So factoring reverses the multiplication process. When you think about what that really means, what is the inverse or the opposite of multiplying? It's dividing. So we're going to factor by finding the GCF. And by factor, we're really talking about dividing. Let's say we have an expression 4x plus 8. What we want to be able to do is find the expression of the two terms and find the GCF of the two terms in the expression. Term 1, 4x. Term 2, 8. So we're going to kind of do this as a two-step process. First, finding the GCF. What I like to do when I find the GCF of the two terms is literally list out, just like when you guys learned factor trees back probably in 4th and 5th grade, the prime factors of each term. What numbers get multiplied together to make 4x? What times what is the product? Gives me the product 4x. And when I think about that, I know that if I multiply 2 times x, that's going to simplify to 4x. I want to do the same thing by breaking down 8. And most of us start with a factor tree of 4 times 2. 2 is already a prime number, so we're going to break down the 4 to 2 times 2. So 8's prime factorization would be 2 times 2 times 2, or 2 to the 3rd power. And 4x would be 2 times 2 times x. What I want to do next is I want to go through and circle whatever they have in common. And I see in my first list of 4x, there's a 2, there's a 2. Let's go back to 4x. There's another 2 and another 2. What circling does is it helps me to then identify what is the greatest common factor. Well, when I see two 2's under each list, that tells me that the GCF has to be equal to 2 times 2. The product of 2 and 2 is 4, and that there is my GCF. What I then like to do is, in another color, I like to circle my leftovers. What isn't part of the GCF? I'm actually going to box those. What isn't a part of my GCF, what's left over, is an x and a 2. And you're going to see in a second where that comes in. Now we're ready to go to step 2, factoring out the GCF. There are two ways to do this. When we go from standard form to factored form, we know that the format is going to have a number and a set of parentheses, and in this case we're working in terms of addition, so a little plus sign there. How do I decide what goes where? Well, here's how we decided. We're going to take our GCF and we're going to place our GCF in that outside spot. We already identified the GCF as 4. I'm going to place that there. Now what we need to figure out is what still is left to go inside. Two ways to do this. The first way literally would be to factor out or divide each term of the expression by 4. Well, when I divide 4x by 4, what am I left with? Well, 4x divided by 4 leaves me with x. And 8 divided by 4 is 2. And this here now is my factored form of the expression 4x plus 8. You may notice back from this first, the left side of the screen, our GCF was identified as 4. Notice that that GCF is that outside number. My leftovers, right, that's what's left after I factored out, after I divided. What's left over is what you're going to notice ended up inside of the parentheses. The other thing you may notice is as we divided each term, the remaining simplified numbers are what's left in parentheses. So our factored form of 4x plus 8 becomes 4 times the quantity of x plus 2. Let's try another one just to make sure we're really understanding this. Okay? We'll do the same 2 steps. We're going to look for the GCF of the expression 5x plus 15. So I'm going to start by listing the factors of 5x. Well, this is an easy one because 5x is made up of an expanded form 5 times x. Okay, so those are the factors of 5x. Now I'm going to find the factors of the second term, 15, 5 times 3. Remember, what we're going to do is look for what's in common. We call that the GCF. Okay, well, what do they have in common? I see a 5, I see a 5. Okay, remember what I'm going to do here also. Even though I'm not going to use these quite yet, I'm going to box up my leftovers because I know that my leftovers are going to go here inside of parentheses, and it's my GCF that's going to go here outside of the parentheses. So I'm ready to place my GCF where it belongs in the problem, and I want us to think about this in 2 ways. Not only are the x and the 3 the leftovers, but think about when we factor, when we divide each term by the GCF, 5x divided by 5 gives us a value of x. 15 divided by 5, right? We're dividing by the GCF. 15 divided by 5 gives us 3. What you're going to notice is my GCF and my leftovers, right? My GCF is 5. My leftovers from my factoring are x and 3. Do you see the pattern of where those go when we rewrite the problem in factored form? That's what we're looking for. All right, let's see if we can try a couple of examples, maybe with some shorter steps. So we're going to start with 3x plus 21. What's probably going to start happening for you guys is you're going to probably begin to be able to do these steps a little bit faster. I'm looking for my GCF of 3x and 21. I know that 3 times x, 3 and x are the 2 factors of 3x. 3 times 7 are the 2 factors of 21. I automatically know that my GCF is 3. When I think about factoring that out, my leftovers, when I divide 3x by 3, are x. When I divide 21 by 3, I get 7, and here we go. When I factor the expression 3x plus 21, I end up with 3 times the quantity of x plus 7. Okay? We'll do the same thing for 8x minus 24. My GCF, you might already be able to notice this just by looking at the 2 numbers. I know that 8 is a factor of 8 and a factor of 24. My GCF is 8. I'm going to get to the point where I don't have to necessarily do those factor trees to figure it out, okay? What's left over? Well, 8x divided by 8 is x. 24 divided by 8 is 3. Here we go. 8 times the quantity of x minus 3, or 8 times the quantity of x plus negative 3. All right, here's a tricky one. We're going to actually factor this one out. My factors of 6x squared are 2 times 3 times x times x. 2 times 3 times x to get 6x squared. My factors of 2x are 2 and x. Let's circle what they have in common. I see a 2 and a 2 and an x and an x, which means my GCF is 2x. My GCF is 2x. What are my leftovers? 3x. And when I have nothing left for 2x, my GCF, or my leftovers, I should say, are 1. When nothing is left, the leftovers are 1. So, what's left? 3x and 1. When I factor out and divide 6x squared by 2x, let's put that in its right spot. 2x is my GCF. When I factor out 6x squared divided by 2x, I am left with 3x. If I'm unsure, I can look back at my factor tree and see my leftovers there. What's left when I factor out a 2x from 2x? Well, identity. It's 1. It's identity property. The factorization, or the factored form of 6x squared plus 2x is 2x times the quantity of 3x plus 1. If ever you're unsure, I'm going to leave you with this. You can always go back and check it. Let's go back to this first problem. Think to yourself, what are we trying to get this to in standard form? 3 times x is 3x. 3 times 7 is 21. Go back and forth between the two forms. Make sure that you're on the right track. Let's check the next one. 8 times x, 8x. 8 times 3, 24. And the last one. 2x times 3x. Well, I know that 2 times x times 3 times x gives me a product of 6x squared. 2x times 1, identity property, is 2x. All right? I think you know how to factor now. Good luck with the homework. Have a good weekend.